All right, welcome. So last time we talked about measurements of center, and we did talk about spread, we talked about variation, but let's talk about measures of variation now. So remember, the two basic things I talked about that I said we talk about fundamentally when it comes to data is we want to know where the center is and we want to know where what the spread is around the center. Okay, so now we're going to talk about measures of that variation. So let's take a look at these two banks, right? So we're talking about waiting times at two different banks. One is Big Bank, and they have 3 lines for tellers. And then we have Best Bank that has 1 line, one waiting line. So we're going to consider the 11 waiting times of customers at these two banks, okay? So what are we going to do? Well, we can calculate things. We can calculate the average, and then we can create a histogram. We can look at the graphs, right? So let's see what we can get from this. Okay, so here we go. So here's the 2 histograms. Notice that for Big Bank, we have much higher variation than with Best Bank, right? So notice, look how spread out those waiting times are compared to Best Bank. Now notice also that both of these are centered around 7 and 8, right? They're both centered in the same spot. So they both have the same center, it looks like, but definitely one is more spread out than the other. One has more variation in the waiting times than the other, right? So Big Bank has higher variation than the waiting times at Best Bank. Okay, so now which bank is likely to have more unhappy customers? What do you think? Do you think it's going to be Big Bank or Best Bank? Think about that for a moment. Okay, let's see what we're doing. It's going to be Big Bank because of the surprising long waits, right? So here's the thing: more variability in this case. Less variability means that, hey, I could be waiting as long as 11 minutes, or I could be in and out in 4 minutes, okay? But there's less consistency, right? So if I go to the Best Bank and they're more consistent, I know, hey, when I go in there, I'm gonna be in there 7 to 8 minutes, then you know what? I know what to expect. But if I go in there and I'm told, hey, the average waiting time is 7.5 minutes, right? And I go in there, okay, well, the average waiting time 7.5 minutes, and I end up being there for 11 minutes. Am I going to be happy? No, probably not, okay? Especially if I'm in a hurry. So having just the center of a data set usually is not enough information, right? So you can have an average of 2 data sets, like in this case, but the spread of the data is going to be just as important as where the center is. So if I know that the average is 7.5 minutes, right? But I want to know, hey, how spread out is the data? Because that's another piece of information that's going to influence me, right? Because, hey, just because the average is this, but hey, it could be as high as this or low as this, that's going to make a difference. So that's why it's important to know not just the center, but how spread out it is. Okay, so now here's the first measurement of spread that we're going to talk about, variation. The range of a data set is just the distance between the highest value and the lowest value. So it's max minus min. Okay, the range is a crude calculation. It's not very reliable, especially if you have outliers or extreme values in your data set, because the max and the min could be way out there. Okay, so, but it is a good starting point. It gives you an idea of how spread out the data is. So again, just remember, range is max minus min. Now, consider the 2 of the following quiz scores, because again, this is where I'm leading as far as with the range, and why we really don't want to use the range as the end all be all. Okay, so let's look at these scores. So here's quiz 1. Quiz 1 looks like we have these scores. Most of them, all of them got 10s except 1. So one person failed the exam, didn't study, must have been a really easy exam. and apparently didn't study for it. Okay. And so quiz 2 is here. So let's see, you got 2, right? 2 through 10, right? So it's all pretty spread out evenly, it looks like. Okay. And so the question is which set has the greater range? Okay. So, well, if we take the range of the quiz 1, so that's going to give us 10 minus 1, which is 9. So that has a range of 9. And the range of quiz 2 is going to be what? 10 minus 2, which is 8. So quiz 1 has the higher variation. Right? So then the second question says, would you also say the scores in the set are more varied? So quiz 1 has the higher range, but would you say that that has is more varied or less varied than quiz 2? Well, in this case here, most of the class got 10s. So this is going to be more compact around 10. So this is going to have a lower variation than quiz 2, even though the range is larger. So again, why is that? Because we've got this extreme value in quiz 1. Somebody got a 1, everybody else got a 10. So that 1 is an outlier. It's an extreme value. So that's going to affect the results, right? And so the range in this case would be misleading because of that outlier. So remember what I said, you know, it's something you could calculate relatively quickly, get an idea of what the spread is, but again, it's not something I would hang my hat on. All right. Let's talk about quartiles. So quartiles is a way of partitioning data sets. So we've got 3 quartiles. The first quartile is also called the lower quartile. It divides the lower fourth of the data set, okay? The lower fourth from the upper 3/4. So before we get any further into this, quartiles partitions the data into 4 equal parts, where 25% of the data is in one piece. So each partition has 25% of the data, okay? So how do we get these quartiles? Really easy. The first thing is you have to split the data in half. So you have to find the median. And then to find the other quartiles, right, you have to divide the upper half and the lower half into 2 equal pieces. And then you have your quartiles. So the lower quartile divides the lowest fourth from the upper 3/4. So it's the lower 25%. Okay? And the lower quartile is the median of the lower half of the data set. That's the easiest way to find it. It's the median of the lower half. The middle quartile is the median. So we've already talked about that. So that's also the second quartile. So again, this is the lower quartile. This is also notated as Q1. So the first quartile or lower quartile is Q1. The median or the middle quartile or second quartile is Q2. And then we have the upper quartile or the third quartile, which we denote Q3. And that divides the lower 3/4 of the data from the upper 1/4 of the data. So this would be, you know, where the lower 75%, right? Or the upper 25%. Okay, so those are the 3 quartiles. Now, the 3 quartiles, along with the max and min, are what we call the 5-number summary for a data set. Okay, so all we need is we need the minimum, the lower quartile, the median, the upper quartile, and the maximum to have our 5-number summary. And then with the 5-number summary, we can construct another type of graph called a box plot. Okay, where we have a rectangular box in the middle that encloses the lower and upper quartiles. That's what we call the interquartile range. So that box, as you'll see, the middle box is constructed using the upper and lower quartiles. And then we have a line that marks the median. And then we have whiskers that extend from the box to the max and min. And so this is actually called the box and whisker plot. So let's take our 5-number summary for the big bank. And I highly recommend that you get practice in verifying these numbers. You know, it's always good practice to get these quartiles, okay? In fact, if we go back to these ranges, okay? So if you notice here, they're already ordered, right? So if we find the median, they're already ordered. There's 11 waiting times, so there's a middle. So the median is in here. So how do we find the middle? Well, we just divide it in 2. So in this case here, the easiest way to do it is add 1, which equals 12, divide by 2, and it's going to be the 6th place. So it's ordered. So remember, step number 1, you order the data. So now we're going to do is count either from the top or the bottom, it doesn't matter. So we're going to count 1, 2, 3, 4, 5, 6. There it is. So 1, 2, 3, 4, 5, 6. Notice they both have the same median. Okay. Now we're going to find the upper and lower quartile. So what we're going to do is we're going to take the lower half. Now we're going to exclude the median. We do not include the median in the upper or lower halves. So now if we look at the lower half, we find the median of the lower half, which is going to be what? We have 1, 2, 3, 4, 5, 6 values. Or no, we have 1, 2, 3, 4, 5 values. I'm sorry. So 5 values, which means we're going to find the median of the lower half, which is going to be 5.6. And then we find the median of the upper half, which is going to be 8.5. So now we found our 3 quartiles. And then of course we have our min and max. So there's our 5-number summary. So we do the same thing for best bank, right? So we take the lower half and we find the median of the lower half. And then we take the upper half, we find the median of the upper half. And now we find the minimum and the maximum, and we have our 5-number summary for best bank. And that's where those numbers come from. So let's go forward. Okay. So now, with our 5-number summaries, now we can construct a box plot for each bank. So let's do that. So now this is a side-by-side box plot, or parallel box plot graph, right? So the bottom box plot represents big bank. The top box plot represents best bank. And you can obviously see that the waiting times, you can see how spread out the bottom box plot is. So you can definitely see that the variation of waiting times is higher with the big bank versus best bank. Okay. Notice also a couple of things. The spread, right? So this box here from 5.6 to 8.5 is the distance between the lower and upper quartile. This is what we call the interquartile range, or the middle 50%. So you know that the middle 50% of the data is in that box. Okay, so that's good information to have. But also we also notice that 25% of the data is going to be here, 25% of the data is going to be here, right? And likewise with the smaller box plot. So that also gives you more information right away that is helpful. Now, the most common calculation, the most common statistic that we use, or measurement, I should say, measurement of variation that we use is standard deviation. And the reason why we use it is it's very easy to understand. It basically tells you the typical distance a value is from the mean. Okay, and so to calculate the standard deviation, we use this formula. We are going to calculate deviations, right? So I'm going to show you what a deviation is. We're going to calculate all the deviations from the mean. And then what we're going to do is we're going to square all of those deviations. And then once we square them, then we're going to add them all up. And that's going to give us our numerator. So that's going to give us the value that goes on top. And then all we do is divide by the sample size minus 1. So we're going to take the total number of data values, subtract 1, and that's going to go in the denominator. Then we're going to take the square root of that, and that will give us standard deviation. Okay, now let's use steps to help build the formula. Okay, so instead of memorizing the formula, let's see if we can build it. First, we want to compute the mean. We need the we need the mean of the data set in order to do this, right? It's part of the process. So we're going to have to know what the mean is. So we're going to calculate the mean. And then what we're going to do is to find the deviation, we're going to subtract the mean from each of the data values, because we're going to find how far each and every data value deviates from the mean. Okay, so we're going to take the data value and subtract off the mean. Every single data value, we're going to subtract off the mean. That's going to give us our list of deviations. Then what we're going to do is we're going to find the square of those deviations. Why? Because what's going to happen is some of those deviations are going to be below the mean, and some of them are going to be above the mean. So that means deviations are going to be negative. Some deviations are going to be positive. If we leave them as negative and positive, then what happens is that when we add them all together in the formula, we're going to get a value that's going to be very, very close to 0, which is going to be meaningless for us. So to avoid that, one of the options that we do is we could square them all, right? If we square a negative number, it becomes positive. So if we square all of the deviations, that gives us all positive numbers, which is good, which is what we want. So step number 2 is we're going to find the squares of all of the deviations from the mean, okay, from step 1. And then step 3 is we're going to take all of those squared deviations from step 2 and we're going to add them up. And then step 4, we're going to divide the sum that we got in step 3 by the total number of values minus 1. So we're going to take the total number of values in the data set, so the sample size. We're going to take those values, however many number we have, we're going to subtract 1 from that count, and then we're going to divide the sum that we got in step 3 by that number. And then 5, the standard deviation would be the square root of what we got in step 4. All right, so now the range rule of thumb. Okay, so now if we wanted to approximate the standard deviation, okay, what we would do is we would use this rule of thumb formula. And all we do is we take the range and divide by 4. Now, again, we want to be careful with this because, again, the range is very sensitive to extreme values or outliers. Okay, so this will give us an idea. Like I said, it's a rule of thumb, but it really works more for symmetric data than it does with skewed data. Okay, but nonetheless, it will give us a rule of thumb. So anytime we want to estimate what the standard deviation is, one starting point would be is to take the range and divide by 4. Now, if we know the standard deviation of a data set, then we can estimate the high and low values as follows, right? So the low value in the data set, would not necessarily the mean, right? But a low value in the data set, we would take the mean and we would subtract off 2 standard deviations. That would give us the low value in the data set. Okay. To get the high value in the data set, not the max, but a high value in the data set. We would take the mean and we would add 2 standard deviations. So basically what we're doing is we're going 2 standard deviations below the mean, and we're calculating 2 standard deviations above the mean to get a high value and a low value. Okay, so let's look at this example here. So studies show that gas mileage of a Prius under varying driving conditions shows that it gets a mean of 45 miles per gallon with a standard deviation of 4 miles per gallon. Okay, estimate the minimum maximum gas mileage that you can expect under ordinary conditions. So what we're doing is we're saying, okay, how can we get most of the gas mileage, right? So what would be the low value and the high value? So what we're doing is we're saying, hey, the vast majority, we're assuming the vast majority of gas mileage that we can get is going to be within 2 standard deviations of the mean. That's what our thought process is. So if we can find the low value and the high value, then we know that we know that most of the gas mileage for this particular car is going to be between these values. So let's do that. So we're going to take the mean and we're going to subtract off 2 standard deviations. We know the standard deviation is 4 with a mean of 45. So we're going to take 2 of these standard deviations. So that means 8. We're going to subtract off 8 from 45 to get 37. And then we're going to do the same thing, but we're going to add 8 to the mean. And if we add 8 to the mean, we get 53. So our low is 37 and our high is 53. Okay? And that's what gives us a range of values to work with. Okay? And so, yeah, you could call it the max and min, but in reality, we're just trying to get the low value and the high value for a range of possible values. And by doing that, we know that we'll have the majority of values based on 2 standard deviations. So remember that. It's always, whenever we base on 2 standard deviations, we're looking for a range that will what's the word that I'm looking for? That will contain all of the most of the values that you will have, in this case, gas mileage. All right, that's it. You enjoy your day, and we'll talk next time. Bye.